Okay, so example 2. Determine if each relation is linear, quadratic, or neither. So I'm going to zoom in, and I'm going to do my first differences. My first differences are going to be -1 subtract -5. So negative and negative gives me a positive. So it's 1 plus 5 is 4. It's going to be 3 subtract -1 is 4. It's going to be 7 subtract 3 is 4. 11 subtract 7 is 4. 15 subtract 11 is 4. Those are my first differences. They're all the same. Guess what that makes this? Linear, since the first differences are all the same. Let's look at the second one. 4 minus 2 is 2. 8 minus 4 is 4. I already know it's not linear. It's non-linear. 16 minus 8 is 8. 32 minus 16 is 16. 64 minus 32 is 32. So it is non-linear. The question is, can we do better? Can we look at the second finite differences? So 4 minus 2 is 2. 8 minus 4 is 4. 16 minus 8 is 8. They're not the same. So it's not quadratic either. So it's not quadratic. So it's non-linear, not quadratic. So I guess we would call it neither. But the problem, so it's not line, it's not quadratic, it's neither. And the last one, my first finite differences. So what did it take to go from 4 to 1? -3. What did it take to go from 1 to 0? -1. To go from 0 to 1? +1. That's another way to do these values. What did it take to go from 1 to 4? +3. And from 4 to 9? +5. So my first finite differences are not the same. It is non-linear. But the question is, can we do better? Let's take a look. The second finite differences, what did it take to go from -3 to -1? +2. What did it take to go from -1 to +1? +2. From 1 to 3? +2. From 3 to 5? +2. These are all the same. That makes this quadratic. There you go, guys. That's the end of this. I'll post a little performance task for you to do, and that'll be that unit done.